Hello, our project is integrating IoT with health record management system using IPFS and blockchain technology. I am Gargi Bumhare.
I am Wasim Khan.
And I am Pradnya Pugawkar. So let's start with the description. So first let us know why we need blockchain based health record management system. So as many countries are suffering from a dramatic increase in number of patients and it is becoming more difficult for patients to access primary doctors or caregivers. And in recent years, the rise of IoT and wearable devices has improved the patient quality of care by remote patient monitoring, which allows physicians to treat more patients effectively. Remote patient monitoring provides monitoring and care of patient outside of the conventional clinical settings, and the data which is received from the patient using the IoT devices is very sensitive and personal, which needs the utmost security.
So, our project focuses on providing the solution for this issue by storing the data in a more secure manner using blockchain, which is a system of recording information in a way that makes it difficult and impossible to change, hack, or cheat the system.
Here, we are addressing privacy and security issues of IoT devices for maintaining medical records using blockchain technology. And for this, we have divided our project into 3 parts, which is IoT, second is website, and third is blockchain.
So, moving forward with the IoT part, the raw sensors data from patient's body is collected by sensors which are connected to Arduino Uno. With the help of Wi-Fi module, the data will transfer to the cloud. From there, it is fetched on the website for real-time monitoring.
This is our patient monitoring device. Here we have used Arduino Uno, which is connected to the ESP8266 Wi-Fi module. And here is the pulse rate sensor, and this is the LM35 body temperature sensor. So this all these data from the sensor is connected to the ThinkSpeak IoT cloud. So here you can see all the data on the ThinkSpeak cloud, and this is the website which we have generated. So when you log into the website, so this is the patient dashboard, and here you can see the patient's information. This is the body, this is the pulse rate of the patient, and this is the body temperature of the patient, and here is the all the past records of the patient of the pulse rate and as well as the patient body temperature.
So coming to the blockchain part, we have implemented a Dropbox type decentralized application that runs on blockchain and also the interplanetary file system IPFS. This will allow users, the patients, to upload files in a decentralized way and also share it with doctors in a trustless, censorship-resistant fashion. For this, we have used React.js for UI, TruffleScript for smart contracts, smart contracts testing and deploying, and Ganache, which is a local Ethereum blockchain network used for development and testing purpose. And lastly, we have used the IPFS, Interplanetary File System Protocol. IPFS is a peer-to-peer file storage protocol which can store large amount of files in a decentralized peer-to-peer format. Let's take a look at how the application works with the help of an activity flow diagram. First, the patient reacts with the website and uploads the report on the website. These reports are then sent to the IPFS, which generates a hash value. This hash is also known as content identifier or CID. This content identifier is then stored on Solidity-based smart contract, which is finally stored on the Ganache blockchain network. And for the doctors can view the reports via the help of content identifier, which is fetched with the help of smart contract and displayed on the doctor's dashboard. So now that we have seen the working of the website, let's see a quick demo of the same. So first, the patient has to write a description about the file or report he or she is sharing. So I'll write here blood test. test report, and then choose a file, appropriate file which he or she wants to share. So reports, and here's a blood test. And once you click upload, a MetaMask transaction, MetaMask is the wallet that connects the network. So a MetaMask transaction is initiated where you can see the account which the transaction from which the transaction is happening and the estimated gas fee. So for every transaction to be implemented in blockchain, a certain amount of a gas fee has to be paid for the same. So the estimated gas fee here is 0.00741 ETH, and the total amount that needs to be paid for the transaction is 0.0074. So we have implemented this in the local blockchain network, that is Ganache. If it is implemented on the main net, Ethereum main net, so then it will take real ethers for the transaction to execute. So as we are using test network, we don't have Ganache provides us with 10 different accounts, demo accounts with 100 ethers in each. So we are using that account here. And once I confirm the transaction, I'll get a pop-up. So here you can see ID number 23 blood test, and the name of the file that I have uploaded, the description I have added, and the type of the file as well, and size also, and the timestamp as well. So the doctors can check when and where, when and at what time the patient has shared the report. And the most two important fields are the patient hash and the view report. So patient hash is important because it is the only way that a particular patient can be identified, because every wallet has a unique hash, and due to this patient's hash, a wallet hash, we can map different patients in the database. And you can also view this on the etherscan website. Since it is a dummy account, there are no the balance is zero, and no transaction has been happening from this account. So yeah, and coming to back to the website, view report. So this is the hash which is generated by the IPFS protocol, and once you click on the view report, you can see that image. Exactly, antivirus. You can see the report here, and the it is the same report which I have uploaded. And since the doctors can only view this report, they cannot edit or download this report. It creates a trustworthy environment between the patient and the doctor. So this is the main goal that we are trying to achieve with this system, to create a trustworthy environment, trustworthy and safe environment for sharing reports. And you can also see the same in the Ganache blockchain. This is the Ganache control panel, and here you can see in the blocks the new block number 39 is added at today's date, that is 2 2nd of August 2022, the time of recording. And you can also see the gas used in for the transaction, that is 24703. This is in GUI. GUI is the smallest amount of ether, smallest unit of ether. So it comes as a big number, but it's not actually very much amount. And here you can see the detailed view, the gas used, mined on, and you can also see the block hash. This is the important part where with which you can identify any particular block in the chain. This is unique for every block. And there is also the transaction hash. The transaction hash you can see here. So this is also unique for every transaction, and you can see the from address and to contract address. So this is what the from address is the address from which the patient's address from which the transaction has happened, and the contract address is the contract address is the smart contract which we have developed, and the transaction is being mapped to that smart contract and then stored in the blockchain network. So this is the that address. This is the smart contract address which the transaction is mapped to, and this is all about Ganache. And after that, the main reason for using IPFS in this project is because the blockchain network is secure and immutable, but it also has a size limit. We cannot store large amount of data directly on the blockchain. So for that, a way around is we can use IPFS. IPFS is free and it's peer-to-peer decentralized network, same as blockchain, but it's not expensive. For every transaction to commit on blockchain, for every transaction we have to pay a gas fee. But for IPFS, it's not the same. It's free. So we can directly upload all the file to the IPFS, and the IPFS generates a hash for that. And if uh, you can only access that file with that hash only, and after that if the hash is not available you cannot ever access the file. So without, so we are indirectly storing the hash in the blockchain. So all the file is indirectly being stored on the blockchain, because if the any third party tries to access the file, they need to have this hash, and they cannot have this hash because a blockchain is immutable, and is not possible to hack a blockchain network. Because if anyone tries to change or update the blockchain network, they have to update the entire network. As you can see in Ganache, the set of blocks. So if anyone tries to change a certain blocks, say as in block number 37, so if the data of block number 37 is uh, tampered with, so the hash is linked to the next block as well as the previous block. So if the this hash is tampered with, so even a one bit of a temperation will make the block hash different unique hash. So if the block hash changes, that means the transaction has been tampered. So it's not feasible to hack a blockchain network. That's what makes it immutable, and hence more secure than the traditional store database or a